For years, one name has haunted the world of astronomy: Oumuamua, the first interstellar visitor we ever saw. It was a ghost in the dark, spotted only as it was leaving, a mystery we could no longer chase. It was long, it was fast, and it defied easy explanation. For years we thought it was a lone wanderer, a one-of-a-kind anomaly, a message in a bottle from a star we'll never know. Turns out, we were wrong. The universe is a much busier place than we ever imagined. In the summer of 2025, humanity got a new message. Another traveler from the void between the stars crossed into our cosmic backyard. But this time, it was different. This time, we were ready. It's called 3I/Atlas, and its discovery proves Oumuamua wasn't a fluke. The question is, what secrets did it bring with it? This new messenger is fundamentally different from anything we've ever seen, a possible time capsule from before our own sun was born. And as we peel back its layers, we're forced to confront not just the history of other solar systems, but our own place in the cosmos. Is it just a rock, or is it something more? The answers are finally getting closer. To really get why 3I/Atlas is such a huge deal, we have to go back to 2017. Back to the moment our picture of the solar system changed forever. That was the year astronomers at the Pan-STARRS Observatory in Hawaii spotted something they'd never seen before. An object, designated 1I/Oumuamua, the Hawaiian word for scout, was zipping through our solar system on a path that could only mean one thing: it wasn't from around here. Its trajectory was hyperbolic, a perfect open-ended curve. Imagine throwing a ball so fast it escapes Earth's gravity entirely. Oumuamua was moving with so much speed relative to the sun that it clearly wasn't tied to our star by gravity. It was a tourist just passing through, and it would never return. This was the first time we had ever confirmed an object from another star system visiting our own. The excitement was electric. But that excitement quickly morphed into pure confusion. Oumuamua was weird, incredibly weird. First, its shape. Based on the wild swings in its brightness as it tumbled through space, astronomers figured it had to be highly elongated. The leading theory painted a picture of something maybe 10 times longer than it was wide, like a cosmic cigar or a flat pancake-like shard. Then came the acceleration. Oumuamua was speeding up as it moved away from the sun, pushed by something other than gravity. For a comet, that's normal. Comets are dirty snowballs, and as they near the sun, ice sublimates into gas, creating a little rocket-like push. But here was the problem. Oumuamua had no coma, no fuzzy halo of gas and dust, no beautiful tail. This contradiction created a scientific puzzle that has captivated and divided astronomers ever since. What was pushing it? Was it made of something we'd never seen before, like a solid hydrogen iceberg outgassing invisibly? Was it a nitrogen iceberg chipped off a distant Pluto-like planet? Or was it, as Harvard astronomer Avi Loeb famously and controversially proposed, something else entirely? Was that gentle push from the pressure of sunlight on an incredibly thin light surface? Was Oumuamua an artificial object? A solar sail, a piece of alien tech? The debate raged, but the evidence was thin. Oumuamua was discovered on its way out, a fleeting shadow we could only watch disappear into the darkness. We had no time to get a good look, no chance to send a probe, no way to solve the mystery. It left us with more questions than answers and the profound sense of a missed opportunity. For years we wondered if we'd ever get another chance. And then, we did. The story of 3I/Atlas began on July 1, 2025. One of the telescopes in the Asteroid Terrestrial Impact Last Alert System, or ATLAS network, was doing its nightly job scanning the cosmos. ATLAS is our planetary guardian, a set of telescopes with primary locations in Hawaii and partner sites in Chile and South Africa that scans the entire sky, searching for moving objects, especially asteroids that might pose a threat to Earth. On that night, the system flagged a faint, fast-moving point of light. Initially, it was just another blip in the data stream with the temporary name A11PL3Z. But to human eyes, its path was immediately suspicious. It was moving way too fast, and its trajectory was all wrong. Instead of the gentle, looping ellipses of objects in our solar system, this thing was on a path that looked impossibly steep. The astronomical community exploded with activity. Observatories around the world scrambled to get a look at the newcomer. Data poured in, and astronomers found pre-covery images, pictures taken by other surveys weeks earlier that had accidentally captured the object. With this growing arc of observations, they could plot its orbit with incredible precision. The verdict came quickly. On July 2, 2025, just a day after its official discovery, The Minor Planet Center announced its status and gave it its official name 3I/Atlas. The 3I means it's the third confirmed interstellar object. Its orbital eccentricity, a measure of how much an orbit deviates from a perfect circle, was estimated at a jaw-dropping 6.2. It was moving so fast that our sun's gravity was like a pebble in a river, slightly altering its path but completely unable to capture it. And unlike Oumuamua, which was a ghost spotted fleeing the scene, 3I Atlas was discovered on its way in. This was a game-changer. We had months of warning, months to prepare, months to point our best instruments at this traveler before its closest approach to the sun in late October 2025. This time we wouldn't be left with just questions. This time we could get some answers. From the moment 3I Atlas was confirmed, the ghost of Oumuamua loomed large. Would this new visitor be just as baffling? The first images quickly gave a stunning answer: nope. 3I Atlas was fundamentally different. Follow-up observations revealed what Oumuamua so obviously lacked: a coma. Encircling the object's core was a fuzzy, glowing envelope of gas and dust. This was the telltale sign of a comet. Unlike its mysterious predecessor, 3I Atlas was clearly active. Even at its great distance from the sun, something was causing its surface to fizz with gas and dust. This makes it seem more like our second interstellar visitor, 2I/Borisov, a comet discovered in 2019 that, for the most part, looked and acted like a regular comet from our own solar system. So what does it mean to be a comet? Think of its solid core, the nucleus, as a dirty snowball, a primordial mix of ice, rock, and dust left over from when a solar system formed. As a comet swings in from deep space, the sun's radiation heats its surface. The ices don't melt. In the vacuum of space, they sublimate, turning directly into gas. This escaping gas lifts dust and ice off the nucleus, forming a huge thin atmosphere called the coma. The solar wind and sunlight then push this material away, forming the iconic tails. The discovery of a coma around 3I Atlas was both a relief and a thrill. A relief, because it meant we weren't dealing with a complete enigma like Oumuamua. Its activity could be explained with physics we understand. The thrill came from the opportunity this presented. The coma is a direct sample of the comet's guts. By studying its light with a technique called spectroscopy, we can read its chemical fingerprint. This wasn't just a rock, it was a pristine piece of another star system, actively telling us its secrets. Pinning down its size has been tricky. The bright coma initially confused astronomers, leading to some high-end estimates that the nucleus could be up to 15 or even 20 kilometers in diameter. However, these early numbers come with a lot of uncertainty. As our best telescopes like Hubble get a sharper look, the estimates may shrink. A smaller nucleus would mean the object is less of a statistical fluke, making its appearance more expected. So, here's our tale of the tape. Oumuamua, a small, dry, weirdly shaped object with an unexplained acceleration. 2I/Borisov, a fairly normal comet, a welcome but not entirely shocking visitor. And now 3I Atlas, a very active comet whose true size is still being debated, but whose composition would soon become the most extraordinary part of its story. It was a comet, yes, but one unlike any from our own backyard. The story of 3I Atlas isn't just about an object, it's a story about time. An impossibly long journey from a home we'll never see. To understand this journey, we have to look at its path not just through our solar system, but through the Milky Way galaxy. Its hyperbolic trajectory tells us it's from another star. But can we know which one? Sadly, no. The galaxy is a chaotic dance of billions of stars. Over millions, let alone billions of years, its path would have been nudged and altered by countless other stars and gas clouds, making a direct traceback impossible. However, its trajectory might hold a deeper clue. When astronomers analyzed its path relative to the whole galaxy, they found something remarkable. Our sun lives in the galactic thin disk, a flat, dense plane where most stars are forming today. But 3I Atlas appears to be plunging down through that plane on a highly inclined orbit. Its motion isn't typical of stars in our neighborhood. Instead, its path is a good match for an origin in the thick disk of the Milky Way. The thick disk is a much older, puffier halo of stars that surrounds the thin disk. Think of the galaxy like a vinyl record. The thin disk is the record itself, with all the grooves. The thick disk is a thicker layer of material above and below it. The stars in the thick disk are ancient, some of the galaxy's firstborn. If, and it's a big if, 3I Atlas really does come from a star in the thick disk, it would mean the comet itself is incredibly old. Based on the ages of these ancient stars, some speculate that 3I Atlas could be over 7 billion years old, possibly much older. This is a staggering thought. This small, tumbling ball of ice and dust could be a time capsule from a bygone era of the universe. It may have formed around a star that was born when the Milky Way was still young and chaotic. It was likely kicked out of its home system billions of years ago and has been wandering the lonely interstellar void ever since. We might not just be looking at a visitor from another star. We could be looking at a visitor from another time. The real treasure of 3I Atlas lies not in its speed or its possible age, but in its breadth. As the comet gets closer to the sun, its ices are sublimating, and this is where the story goes from incredible to revolutionary. This is where the James Webb Space Telescope comes in. Observations are planned for the JWST to turn its powerful infrared eyes on 3I Atlas, using its spectrographs to perform a detailed chemical analysis of its coma. Spectroscopy breaks down light into its component colors, creating a unique barcode for every atom and molecule. By reading this barcode, astronomers can figure out exactly what something is made of. Even before the JWST results are in, preliminary data has already hinted at something stunning. Early observations suggest the comet's coma is overwhelmingly dominated by carbon dioxide gas. The ratio of carbon dioxide to water appears to be astonishingly high, perhaps one of the highest ever seen in any comet. In a young solar system, different materials freeze out at different distances from the star, creating snow lines. You have a water snow line, and farther out, where it's even colder, a carbon dioxide snow line. The suspected high abundance of CO2 in 3I Atlas suggests two tantalizing possibilities. First, it might have formed right near the carbon dioxide snow line in its home system. The second possibility is even more profound. Its parent star, if it's an old, thick disk star, was likely low metallicity, meaning it had fewer heavy elements than our Sun. This different chemical starting point could have completely changed the chemistry of its planet-forming disk, favoring the creation of CO2-rich comets like 3I Atlas. If this is true, we could be seeing a recipe for planet formation that's fundamentally different from our own. In short, 3I Atlas is a pristine sample of planetary building blocks from a potentially ancient and chemically different star system. It's teaching us that the recipe for making comets and planets isn't universal. It's a chemical message in a bottle that may have traveled for billions of years to reach us. Whenever a strange new object appears in the sky, it's bound to attract speculation. And in the world of interstellar objects, one name is synonymous with pushing those boundaries: Harvard astronomer Avi Loeb. After famously proposing that Oumuamua might have been an alien solar sail, it was almost inevitable that the debate would flare up again with 3I Atlas. Loeb and some collaborators did publish a non-peer-reviewed paper exploring the idea that 3I Atlas might also be artificial. They pointed to what they considered anomalies, such as its surprisingly large estimated size and a trajectory that lines up unusually well with the plane of our solar system's planets. This hypothesis, however, exists far outside the scientific consensus. The overwhelming majority of astronomers see 3I Atlas as a natural, though fascinating, comet. They point to the clear evidence of a coma and outgassing, features that fit perfectly with a natural cometary body. Every observation so far is consistent with a natural origin. So why do these alien tech ideas get so much attention? Loeb argues that science should be open to all possibilities and that the search for extraterrestrial intelligence, SETI, should include looking for physical artifacts, not just radio signals. He sees these interstellar objects as a wake-up call, forcing us to consider that we might not be alone. Even if the chance of an artificial origin is tiny, he argues, the implications are so immense that we have to at least consider it. While these ideas are compelling to the public, they remain speculative. The scientific method demands we stick with the natural explanation until it's proven wrong. And in the case of 3I Atlas, the natural explanation, that it's a massive CO2-rich comet from deep space, works beautifully. Still, the controversy serves a purpose. It forces scientists to be rigorous, and it highlights the profound questions these visitors raise. 3I Atlas is almost certainly a rock. But the fact that we can now study this rock in such detail and seriously debate its origins shows how far we've come. The arrival of 3I Atlas isn't just the discovery of another weird object. It marks the beginning of a new chapter in astronomy, the era of interstellar reconnaissance. We're shifting from being passive observers of rare events to active investigators of a steady stream of cosmic visitors. The difference between our encounter with Oumuamua and our study of 3I Atlas is like the difference between seeing a flash of lightning and having a specimen jar to catch the rain. Oumuamua was gone before we truly understood what it was. It was a fire alarm in the night, letting us know our solar system wasn't an isolated island. With 3I Atlas, we were ready. Discovering it on its inbound journey was the key. It gave us the most precious resource in astronomy, time. Time to coordinate our most powerful observatories like Hubble and the James Webb Space Telescope to build a complete profile, its size, shape, composition, and temperature, with a precision that was unimaginable just a decade ago. Finding 3 of these interstellar objects in less than a decade, Oumuamua in 2017, Borisov in 2019, and Atlas in 2025, strongly suggests they're far more common than we thought. As our survey telescopes get even better, we might start finding several per year. The trickle of messengers will become a steady flow. Missions are already being designed for this new reality. The European Space Agency's Comet Interceptor mission, planned for launch around 2029, is designed to park in space and wait. When a pristine comet, or ideally an interstellar object on the right path, is found, the mission will be sent to fly by and study it up close. While it's too late to send a probe to 3I Atlas, this visitor is the perfect proof of concept for why a mission like Comet Interceptor is so essential. 3. Atlas has given us our first detailed peek into the nursery of another solar system. It has shown us that the processes that build planets are diverse. We are no longer just stargazers, we are interstellar archaeologists, sifting through the most ancient relics the universe sends our way. From a fleeting shadow to a brilliant gas-shrouded messenger, our view of interstellar visitors has been transformed. Oumuamua opened the door, a bewildering scout that left us full of questions. 3I Atlas has now walked through that door, a potential 7-billion-year-old comet from an ancient star, carrying a chemical story we're just starting to decode. It's a possible time capsule from the dawn of our galaxy, a CO2-rich relic challenging our assumptions about how planetary systems are born. Its journey through our solar system, though brief, is a monumental event. It has proven that we have the technology to turn what was once science fiction into observational fact. As 3I/Atlas makes its closest approach to the sun and begins its long, lonely journey back into the void, it leaves us with a profound sense of perspective. Our solar system isn't a fortress, it's a crossroads. A tiny sunlit harbor in a vast, dark ocean teeming with travelers from distant shores. If you want to continue this journey with us, don't forget to like, subscribe, and share this with anyone who looks up at the night sky and wonders what's out there. The universe is full of mysteries, and together we'll keep exploring them.